Welcome friends, in this tutorial we are going to study about rectifiers. In this video I will cover the following topics: difference between DC and AC, and half wave rectifier, full wave rectifier, and in the last of the video we will cover that how do we get constant DC from fluctuating or rippled DC. So first let's understand what is a rectifier. So rectifier is an electrical device that converts alternating current which periodically reverses direction to direct current which flows only in one direction. The process is known as rectification. What does this mean? Now let us understand. We can understand this in a better way when we have a idea about the difference between DC and AC. Whenever we are going to discuss about DC, so something which comes in our mind is that it's having a constant value, but no, you are wrong here. These graphs are also DC, means DC nothing. DC is simply current or voltage which is flowing in one direction, means it's having either positive or negative values. See, in this second graph you can see there are many types of DC. This is also DC. This is constant or direct current or direct signal. This is fluctuating or pulsating, and we can't consider this in any signal because it's having a variable value, while alternating current is something which repeats itself from time to time, and the time of repetition is known as time period, while DC can be any signal, right, but flowing in only one direction. Now let's move ahead and now trying to find out the types of rectifiers which we are going to cover. So rectifiers, we are going to cover mainly half wave rectifier and full wave rectifier. In the full wave rectifier we are going to cover full wave center tapped rectifier and bridged rectifier. Now then coming to the half wave rectifier. So let's understand how a half wave rectifier works. This is nothing but a simple diode. Simple diode allows the current to flow only in one direction when it is in forward biased. Yes, what do we mean by forward biased? Means this is a P terminal and this is N terminal. When the P terminal is connected to the plus and N terminal is connected to the minus, or the voltage across PN junction is positive, then it is called in forward biased and it allows only that voltage to pass, and this works as a closed switch. So for the positive lobe, positive pulse, it is working as a closed switch and returns the whole value as the signal, while when the negative lobe appears or negative values comes, it simply goes in the reverse bias, and this works as a open switch. Open switch will not allow any current to flow. Now coming to the full wave center tapped rectifier. So here this is the circuit. We can see here that we have tapped the transformer from its midpoint. That's why it's called center tapped rectifier. So now let's understand that between two terminals voltage is always positive to negative. So suppose I'm applying 10 volt, so this will be like 5 volt, 0 volt because it's a ground, and this is minus 5 volt. Now during the positive cycle what happens, this plus 5 volt is applied to the P type, right, of this diode. So what happens, this diode works as a closed switch and the current flows from this resistor and goes back to the ground. Now during the positive cycle, this is a ground and this is minus 5 volt, so this diode will not work because it's in reverse bias condition. Now again during the negative cycle, this is negative and this will be positive cycle, positive. So now D2 diode second will get forward biased and D1 will be in the reverse bias condition because this is ground, so 0 voltage, and this will be minus 5 volt. So now this diode will work as a closed switch, and again the current will follow I2 this path. Again this will go in the same direction, means from top to bottom. It means that we have arranged it in such a way so that both the diodes are connected. It means that at one point one diode will act, and this will transfer the current only in one direction. This is what we need, means during the positive cycle or negative cycle the current flows in only one direction, right? In positive cycle it flows in from top to bottom, and even from the negative cycle it again flows from top to bottom. This is how our full wave center tapped circuit works. Now coming to the full wave bridge rectifier. So here we can see this is a circuit, and this circuit comprises 4 diodes. So all the 4 diodes are again arranged in such a way so that we can find this current in only one direction to flow. Now how does this circuit work? For example, when during the positive cycle this terminal is plus and this will be minus, so the diode D1 will be forward biased during the positive cycle and D3 will be reversed biased, because N terminal of the diode is connected to the positive cycle, that's why it's reversed biased. Now this D1 will be forward biased and the current will come to this node. Again there is 2 paths. There are 2 paths, D4 and load resistor. So D4 is also reversed biased. You can see because positive, because it's working as a switch, closed switch, so the same voltage will appear here also. Now this will work as a reversed bias and current will follow this path. Now there is a confusion that this is also forward, this is also forward. So how can we decide that in which direction the current will flow? Now to avoid this problem, suppose we are connecting this to the ground, right? Now this is positive, this is negative. Suppose +5 -5, so this terminal D2 is connected to the -5 and this is +5. This is ground because this all the wires is grounded. Now ground and +5, ultimately voltage across this D3 is -5 volt from plus to minus. So this is reversed bias, so current will flow in this direction. It will appear, follow this path D1 RL and again D2 and complete the circuit. During the negative bias, negative circuit, what happened? Negative wave, this is plus and this is minus. Same process will occur here. This is plus, this is reversed bias D2, D4 is forward biased, and D2 will be in the reverse biased. Again means this is positive, this is, in this way we can find out that this is a negative voltage. So again this is forward bias and this is reversed bias, so current simply go from this to this path. Now coming to the last part of the tutorial, getting constant DC from rippled DC. So how do we get that? We simply add a capacitor parallelly across the load resistor. So this capacitor will store the voltage across it, and we will find this same voltage for some time. Then next pulse will come and we will again get the same. So in the last we found this ripple means ripples output waveform, full wave rectified output waveform. What happens when we connect the capacitor across parallelly across the resistor? So capacitor stores the voltage, again it maintains it and continues at the constant value. Thank you very much. I hope the video was quite helpful for you, and please comment if it was really helpful.